What if the most powerful warship ever built is already on the verge of becoming obsolete? The USS John F. Kennedy, a $13 billion nuclear-powered supercarrier, is the crown jewel of American naval engineering. It's massive, menacing, and designed to dominate the seas for the next 50 years. But here's the twist. In a world racing toward hypersonic missiles, AI-driven swarms of stealth drones, and satellite-targeted precision strikes, can a 100,000-ton steel titan really keep up? Or is this floating fortress just a shiny target waiting to be taken out? Today, we're digging into the high-stakes gamble behind the Navy's next-gen supercarrier and asking the question the Pentagon won't. Is the USS John F. Kennedy the future of war, or a $13 billion mistake? To understand the USS John F. Kennedy, you have to understand what aircraft carriers used to be and what they're becoming. For nearly a century, these floating fortresses were the backbone of American power projection. From the Pacific battles of World War II to modern conflicts in the Middle East, aircraft carriers were often the first to arrive and the last to leave. Entire battle plans were built around them. When global tensions rise, one question always gets asked first: where's the nearest American carrier? But the battlefield is changing. Wars aren't always fought with tanks and troops anymore. They're fought with code, drones, satellites, invisible weapons that strike without warning. And while the world gets faster and more unpredictable, the carrier, massive, slow, and highly visible, becomes more of a symbol than a shield. So why invest billions in a ship the size of a skyscraper on its side? Because the USS John F. Kennedy isn't just a bigger version of the past. It's an attempt to future-proof naval warfare. And the first clue to how it plans to do that starts deep within its nuclear-powered core. Beneath the deck of the USS John F. Kennedy lies its most important secret: two nuclear A-1B reactors that generate a staggering 700 megawatts of thermal power. That's enough energy to power an entire city, or more importantly, to run every advanced system on the ship at once, with room to grow. Compared to the Nimitz-class reactors that came before, that's a 25% jump in raw output. But the real leap isn't just in power, it's in what that power unlocks. The Kennedy ditches old-school steam catapults and hydraulic arresting gear for two revolutionary upgrades: EMALS and AAG. EMALS, or Electromagnetic Aircraft Launch System, uses linear motors to hurl jets off the deck with precise acceleration. It's lighter, cleaner, faster, and it eliminates the need for giant steam systems below deck. More importantly, it's gentle. It puts far less stress on the aircraft frame, which means more launches, less maintenance, and a new door wide open for cutting-edge stealth drones. Then there's the AAG, the Advanced Arresting Gear. Think of it as the EMALS in reverse. It uses electromagnets to stop aircraft with smoother force. Why? Because tomorrow's warplanes aren't just manned. Drones are lighter, more fragile, and weren't compatible with older hydraulic systems. The Kennedy's arresting gear was designed with that in mind. This isn't just about launching jets. It's about launching the future, and doing it hundreds of times a day. But raw energy and smooth landings are just the beginning. Because when you're flying dozens of missions a day, you need weapons. Fast. Power means nothing without firepower, and the USS John F. Kennedy was built to feed the fight faster than any carrier before it. Buried beneath its massive flight deck are 11 electromagnetic weapon elevators. These aren't your typical clunky lifts. They're fast, moving it up to 150 feet per minute, and they're strong, hauling 24,000 pounds of ordnance in a single trip. But the real genius? These elevators never cross the aircraft movement zones. That means bombs and missiles can be moved directly to waiting aircraft without clogging up flight operations. What once took hours now takes minutes. In combat terms, that's the difference between 180 sorties a day, the limit for Nimitz-class carriers, and up to 270 for the Kennedy. That's a 50% increase in strike capability. And what's being loaded onto those planes isn't just conventional hardware. The Kennedy is built for flexibility, ready to carry a mix of cutting-edge aircraft, including F-35 Lightning IIs for stealth attacks, Super Hornets for strike and escort missions, Growlers for electronic warfare, Hawkeyes for early warning, and the Navy's future workhorse, the MQ. 25 Stingray refueling drone. But that's just the beginning. Quiet whispers inside defense circles suggest something bigger. The return of the X-47B, a fully autonomous stealth drone that was once shelved but might be coming back, this time with the Kennedy as its launch pad. This ship isn't just a runway. It's a launch system for the next generation of unmanned, networked warfare. But to win the skies, you also have to see everything before your enemies do. Seeing first and seeing clearly is everything in modern warfare. And that's where the USS John F. Kennedy made one of its boldest changes. Instead of using the overly complex dual-band radar system from the first Ford-class carrier, the Kennedy was equipped with a leaner, smarter alternative, the Enterprise Air Surveillance Radar, or EASR. On paper, it might seem like a downgrade. The dual-band radar combined S-band and X-band technologies into a single, futuristic system. It was ahead of its time, but also expensive, hard to maintain, and nearly impossible to scale across the fleet. EASR fixes that. It's cheaper, modular, and easier to train crews on. More importantly, it integrates seamlessly across a wide range of Navy ships, from destroyers to amphibious assault vessels. That means shared data, shared targeting, and faster decisions. It's not just radar, it's part of a battlefield network, and it saved the U.S. over $350 million without sacrificing detection range or response time. Sure, we lost the flash of a sci-fi radar, but in exchange, the Kennedy gained something far more useful. A system designed to grow with the Navy's future tech, instead of being trapped by its past. But all the radar in the world means nothing if the enemy's missile is moving too fast to stop. This is the nightmare scenario. A hypersonic missile streaking toward the USS John F. Kennedy at more than 15 times the speed of sound. By the time it's detected, it's already too late. That's not science fiction. That's China's DF-21D and DF-26B. Weapons specifically designed to do one thing: sink American aircraft carriers. They're fast, maneuverable, and deadly. And they raise a brutal question the Navy can't ignore. Can even the most advanced carrier survive a direct hit? The answer, maybe, lies in a new kind of weapon: lasers. 10 years ago, most people laughed off laser weapons as a Star Wars fantasy. But in 2014, the USS Ponce quietly tested a 40-kilowatt laser in the Persian Gulf. It destroyed drones, disabled boats, and intercepted threats, all without firing a single bullet. Today, things have escalated. The USS Preble recently tested Helios, a high-energy laser system with integrated optical surveillance, at 300 kilowatts of focused power. That's not far from the 500 kilowatts experts say is needed to take down incoming hypersonic missiles. And here's where it gets interesting. The Kennedy has the electrical power to run it all, and then some. With over 600 megawatts at its disposal, the ship isn't just prepared for lasers, it was built for them. Add in systems like Aegis or the new and Spy, 6 radars, and you've got a supercarrier that might just shoot down threats before they ever get close. But cutting-edge defense is only part of the story. The real question is, are carriers like the Kennedy even built for the wars we're fighting now? For all its firepower, high-tech systems, and billion-dollar brilliance, the USS John F. Kennedy isn't without its flaws, and critics haven't held back. First, there's the timeline. Construction began in 2009, and here we are in mid-2025, and it's still not commissioned. That's over 15 years of building, delays, redesigns, and cost overruns. In a world where threats evolve by the month, a ship that takes a decade and a half to deploy already feels behind. Then there's the price tag, with an estimated cost of over $11.3 billion, not including research and development. The Kennedy is one of the most expensive pieces of military hardware ever created. And that's just the ship, not the aircraft, crew, weapons, or maintenance. And critics argue the biggest flaw isn't even about money, it's about relevance. In a world of asymmetric warfare, cyber attacks, remote drone strikes, electronic jamming, does a 100,000-ton steel Goliath still make sense? Or is it simply too slow, too exposed, and too predictable to survive in a modern war zone? Some military strategists are sounding the alarm. They say we're investing in prestige, not practicality. and that future wars will be won with satellites and software, not supercarriers. But maybe, just maybe, that's the point. Because the Kennedy's real power might not come from what it does, but from what it represents. Behind the steel, the systems, and the staggering price tag, there's something about the USS John F. Kennedy that most people overlook. It might not be built just for war. In fact, its most important role might never involve firing a shot. Supercarriers like the Kennedy aren't just weapons, they're statements. When one shows up off the coast of a tense region, everything changes. Governments react. Markets shift. Enemies recalculate. That's the true power of a supercarrier, psychological dominance. It tells the world that the US isn't backing down, and that it has the tools, tech, and sheer presence to shape global events. Even in an age of cyberattacks and remote warfare, there's still something deeply primal about seeing a city-sized war machine glide into position. And for allies, it sends a message of reassurance. For adversaries, a warning. So maybe the USS John F. Kennedy isn't just about aircraft or lasers or launch systems. Maybe it's about influence, and the Navy knows it. Because when your goal is to project power, shape perception, and control escalation without ever pulling the trigger, there's still no replacement for a supercarrier. But that raises one final question. Will any of this matter in 25 years? The USS John F. Kennedy isn't just another warship, it's a test. A test of whether the US military can build something that lasts in a world that changes by the minute. A test of whether raw power can still hold the same weight in an era driven by stealth, speed, and software. And a test of whether one ship, no matter how advanced, can stay relevant in the face of weapons designed to end its existence before it even has a chance to respond. This ship was built to serve for over 50 years. But here's the irony. No one really knows what war will even look like in 2075. Will it still involve aircraft? Will carriers even be allowed near combat zones? Or will unmanned swarms, orbital lasers, and AI-controlled fleets rewrite everything we know about naval warfare? What we do know is this. The Kennedy is armed to adapt. With nuclear power, modular systems, and room to evolve, it's not just fighting today's battles, it's bracing for tomorrow's. But whether that's enough is still an open question. So what do you think? Is the USS John F. Kennedy the future of military dominance, or a monument to a fading era? Let us know in the comments. If you enjoyed the video, hit that like button, subscribe for more stories behind the machines shaping our future, and ring the bell so you don't miss what's coming next. Thanks for watching, and we'll see you in the next one.